here we are going to look about the transient problem. uh, Here a uniform flow 3 meter cube per second rectangular channel is 1.5 meter width and the 1.5 meter depth. A smooth rise 0.3 is formed in the channel bed. Determine the depth of flow above the step. What is the height of the step that will produce the critical flow? So these are the questions given here. So if you are if you draw the channel like this, it could be like this. So this is 1.5 meter, then this is also 1.5 meter. They already given q is equal to 3 meter cube per second, and the w area on the given. So if I draw the function, it should be like this. And this is, we can assume, sorry, h1 they given to, or in the question they given 1.5 meter. That is normally the height of the channel. Okay, so the smooth rises is in the 0.3 meter above the channel. So let's assume it's come here. This is 0.3 meter. So they're asking the height above the, determine the height above the step. So they are asking what is this h2 here. So we can put the you can equalize the total energy 1 and 2. Okay, so when you consider the total energy at 1, total energy at 1 is equal to, the equation should be like this. So there is a velocity here, v1 squared upon 2g plus h1 plus there is no elevation difference, so it should be 0. So if we consider the total energy at 2, so total energy at 2 is equal to v2 squared upon 2g plus h2 plus there's a delta z, that is 0.3. Okay, so when you apply the q is equal to av for both sections, first of all we are applying the q is equal to av for the first section. So v1 is equal to q upon a1. Okay, so here we can find the v1 here. How? We already know the q value, area is 1.5 into 1.5, so we can get 1.33 ms minus 1. But on the other hand, this should be different for v2 is equal to q upon a2. What is q? Q is same for the channel, but a2 should be changed here because of the sill here. So the a2 should be like this, q2 upon 1.5 into h2. h2 is the height, so that is the velocity of v. So when you equalize the total energy at 1 and 2, so we can get the equation like 1.33 all then squared upon 2g plus 1.5 so total is 1 is equal to, we can get the value that is 1.59 meter. Likewise we can get the total energy at 2 is equal to v2 squared 3 upon 1.5 h2 whole then squared upon 2g plus h2 plus 0.3. But total energy 1 is equal to total energy 2, right? So total energy at 1 is equal to total at 2. So 1.59 is equal to this one. So we can get, so you can hear that upon 2 into 9.81 plus h2 plus 0.3. From this equation we can get the equation on h2. Actually it's like this one, h2 cube minus 1.29 h2 squared plus 0.204 is equal to 0. So this is the equation for h2. So from here we can find three value for h2. One is 0.35, the other one is 1.13 and is 0.51 meter. It should be meter. Now we have to find the critical height, hc. hc is equal to q squared upon gb squared all in 1/3. That is equal to, normally you can find 0.74 meter. We already know, g already know, b is the top width, that is should be 1.5. So we can find the hc value here. From those value we can rewrite this, we can draw a table, we can draw a graph. Let me show you. A graph should be like this one. Okay, so this is S, specific height, this is specific energy. Okay, this is height versus specific energy graph. It should become like this. So the critical height we already find 0.74 meter. Then we got two values here. For the h2 we got three values. The minus one is not possible, so we have to get which one is right from those two values here. We have to select which is right from two positive value. This should not become, because h2 should be greater than 0. Okay, so in this graph we are going to mark those values in the graph. So the 1.13 is over the critical depth, then 0.51 is below the critical depth. So we can mark as, so here for the certain specific energy, so for certain energy we will get two values for h2. This should be E2. So we will get two values. One is greater than the critical depth, then the only one is less than critical depth. Since the 1.13 is we come here 1.13. Then this is the critical depth, so 0.74. One is less than critical, 0.51. So from these values, one should be the right one, this or this. We have to find which one is right. So we already find the specific energy in the point 1 is 1.59. So it should become here, something like here, right? This is 1.59 meter. We already know E1 always we already know E1 is equal to E2 plus EC because of the elevation difference. So always E1 is greater than E2. So this is E1. You already know this is E1. So water can have to move from E1 to E2, right? So it can be like this way, E1 to E2, or can be like go for here. So we have to choose which path is right, this one or this one. But in this case it's want to cross the critical value, but in this case it's easily crossed. So therefore the H2 value, the most suitable value is 1.13 meter. So H2 is 1.13. So that's why asking in the question, they determine the depth flow above the step. Then the second question is what's the height of the step that will produce the critical flow. So they asking when it will be critical flow, what is the 0.3, I mean delta z, what is the delta z here. So like here I can say like this is delta z. So in the question they gave 0.3. So if it is critical flow, what is the delta z they asking. We already know specific energy is equal to E2 plus delta z. So when here delta z is equal to E1 minus E2. So when E2 comes EC, delta z should be come to delta C. So we have to find the EC and substitute for E2 here, then we can get the delta ZC here. So what is EC? EC is equal to 1.5 into HC. What is HC? We already know the equation. HC is equal to Q squared upon GB squared all then 1/3. So from here you can find the HC, then you can find the EC here, they can substitute for E2 here, then you can find the ZC. ZC is the asking in the question as a critical height of the, sorry, when the critical flow is produced, what is the height of the step. Okay, that's all.